All right, so the first thing we're going to talk about, remember, I'm not going to necessarily write everything that you need to write down. Sometimes I will be saying things, and you need to write them on your own. So the first one I'm actually not going to write down is called postulate. I will spell it for you. Postulate. That is postulate. Postulate. So a postulate, their definition is it is a statement that is assumed to be true. Statement assumed to be true. Just spell it as you can. I'm not going to be judging you on that. If you want my way of thinking it, it's one of those things that, have you ever had someone come up to you and they're like, just trust me. Like, this is true, just trust me. That's what a postulate is. It's something that we can't prove to you. We can't show you why it works. It's just something that we assume to be true. So it's just trust me, this is what it means. So that is called a postulate. We're going to have something called later on called a theorem. And with theorems, I can actually prove them to you. I can show you that they are true. With a postulate, I can't. It's assumed to be true. Assumed to be true. So the ruler postulate. Question. The ruler postulate is every point on a line can be paired with a unique real number. And we'll put a little called a coordinate. That is just kind of a fancy way of saying if I had a number line and I put X and I put Y on there, and I had this ruler, do you see how, whoops, I'll do that. And this is actually straight. I'm going to move this one. Do you see how X is right by, like, so we'll call this would be 4. That would be its coordinate. What would Y's coordinate be? And I can actually use that to find the distance. Did we talk about distance the other day? Okay, so the way we find distance is we would subtract the two. Like, what's the distance from 5 to 10? 5, right? How did you get that? You take 10 and you minus 5. You can even do 5 minus 10. Because we do distance, we do not worry about whether it's positive or negative. Distance is neither positive nor negative. So what did you learn about algebra that takes care of that? So like how come, so we'll do this one. How come the distance from 4 to 11 should be the same as the distance from 11 to 4 if I subtract? We understand this is actually going to be, what is this one going to equal, the top one? What's 4 minus 11? Don't hurt yourselves. Careful. Negative 7. What's the bottom one going to be? Are those two the same? No, negative 7. You want, hey, if it is the same, talk to me after class. We'll exchange money all day long, and I'm going to make a killing off of you. Negative 7 is not the same as positive 7. So how do we take care of that so they are the same? So for distance, we only worry about the absolute value of the difference between the two. Because what happens when you put absolute values, what kicks out? So not what kicks out in an absolute value every single time. Kicks out, I mean what comes out? A positive, sorry. When I say kicks out, I mean what comes out of it. A positive 7. So a negative 7 turns into a positive 7. A positive 7 stays positive 7. You guys should have seen absolute values from Algebra 1, maybe even a little bit before. Does anyone have questions on that? Does that make sense? Questions on absolute values. So when we use distance, what do we put them in? When we do distance, what do we put the problem inside of? No, absolute values. That's what takes care of. That way it doesn't matter. Because really, what's the distance from here to here? It's 7 units. What's the distance from here to here? 7. I don't care whether I'm going forwards or backwards when I'm talking about distance. Does that make sense? It would be like someone saying, I live 100 feet from the school, and someone else says, I live 100 feet from the school. Yeah? One's in this direction, one's in the other. I don't care. They're both 100 feet from, because distance is going to be positive. You want to look, if someone came up to you and like, yeah, I'm negative 100 feet from the school. You'd be like, what are you talking about? That's not how we use distance. That's not distance. Distance and coordinate plane are different. That's the ordered pair. Okay, distance is how far things are apart.
If you make it technical, and like you know, like in specific programs, sometimes you need to like put distance as a negative number because of the fact the way the pixels work. Like the center pixel would be 0, which means over here the distance between that thing from 0 would by the program be negative 100.
Well, what you're talking about on that program would be more of a coordinate plane.
Yeah, what's it?
So coordinate plane you can have negatives, but still the distance from this pixel to this pixel
is exactly 100.
Even if I did from here to here or here to here, they would both be positive numbers. Yeah. Does that make sense?
That always makes sense.
Yeah, so the coordinate plane can be negative. That's kind of what he was talking about, what you are. And yes, you're right. When we do draw things on that, we do use the coordinate plane. It's very similar. Math is used all the time for making those. Questions on the distance? All right, now we get into now you're going to start to see a little bit of geometry today as far as how we use, I think this is kind of fun stuff. Like this is where it gets a little bit real, and we welcome you to math, actual math. So here we go, segment, addition, postulate. When you were in like elementary school, the teacher showed you a problem, right? Then they asked you to do another problem. Wasn't it like identical to the one before? Today, we're going to do problems, and they're going to be similar, but you're not going to do the exact same way. You're going to have to use what's called logic and kind of figuring out like a puzzle on how you can get the information that they're asking you to get. That will make sense in just a second when we do these examples up here. Okay, so here we go. First thing, segment addition. I believe you are going to say, duh, Mr. Martin, that makes sense. I hope so. If you have this, you have, by the way, what are these points? What would we call this? I gave you a phrase for a word for this. Did we talk about collinear?
Yeah.
What are these points? They're collinear because they're all on the same what? Yeah, so they are called collinear. So if these 3 points are collinear and they are written like this, then you're good. Someone tell me what I just wrote up there. What is that? Careful. You were close. Segment AB, remember little subtle differences, right? Segment AB plus segment BC. What do you think that would equal if I took this piece right here and I added it with this piece right here? What do you think you would get? Go ahead. What do you think?
Assuming they're even.
Oh, they're not the same. We can't assume. So that's going to be something we'll talk about in a second. No assume. But look, if I told you AB plus BC, someone help them out. What do you think that would be? Segment AC. That's logical, right? If I said this right here, so this piece right here, plus this piece right here, would make this whole piece right there. That makes sense. That is called the segment addition postulate. Now, you want to see how we use this in geometry? This is what it looks like. And in the beginning, we're going to be nice to you, and we're going to draw things out for you. But eventually, you're going to have to start drawing stuff yourself. So please, big key in geometry, if they don't give you a picture, what should you draw? A picture representing to help yourself out. Pictures will help you big time when it comes to geometry. We're going to talk about those pictures too. I'm going to do something on purpose, and I love that the book did this too. So points F, G, and H are collinear. What did I just tell you with that statement? What does that mean? They are on the same line. Remember, I want you to start taking math terms that are sometimes confusing, and I want you to turn them into your everyday vocab. If you can do that, that means you actually understand what you're talking about. So points F, G, and H are collinear. That all they said is on the same line. It's a fancy way of saying that. If GH equals 16. Does that mean B to Z? What? GH. Did this die on me? Oh, sad, it's dying earlier. What is FH? And yes, it would be segment. When they give that to you, why do we know that that's a segment? It's Brody, right? Why do we know that's a segment? Come on, bigger than that. If GH was a line, what could we not give it if it was a line? We can't give it a length. Because the line would be what? So you automatically know that that has to be a segment because that's the only thing that we can measure. Follow the logic on that? All right, so what is FH? Yes, thank you. All right, now I gave you some more information, didn't I? So this right here is the length between F and G. This right here is the length between G and H. What did they give us? Okay, so I know that G to H is also 16, right? I know that length. Well, if I know that length, how can I use this tidbit of information to help me solve this? What can I do? Okay, so what you're saying is, since I know that this is 2x plus 2, and I know that this is 16, I know those two things are equal. And if I know they're equal, then I can make an equation. I can make an equation that says 2x plus 2 equals 16. And then I can use my algebra skills to work backwards. Are you following this?
Yeah.
So I'm going to minus 2. By the way, when you get problems right in geometry, you're going to feel this sense of accomplishment. You're going to be like, oh, holy crap, like I did that. Whoa, right? You'll feel that, like, because these questions are actually going to take some brain power. It's like solving a puzzle, and you finally complete it, and you're like, hey, I feel smart. Like, that's a good thing that's going to happen this year. So we minus 2. We get 2x equals 14. We divide by 2, careful, and we get x. Okay, hold on. X equals 7. Does that make sense? Now, what do you think some kids do? This happens in geometry all the time. I'm trying to. I've seen this. I've taught this class. I'm trying to help you because you just came from algebra. And this answer will be on, especially if it's a multiple choice test, this answer will be on there. What do you think kids do right now? Oop. They circle the answer and they think they're done. What did the question ask you to solve for? So I would encourage you, when you think you are finished in geometry and you think you have the answer, I would go back and reread the question to make sure you answer the question that they asked you, because they love to trick you guys. And it's not really tricking. It's just you're so used to math being, you do one thing, you get an answer, and you're done, that you haven't actually put thought into something. And I'm not trying to be mean, like, you have to actually think through this and go, wait, did I answer the question they asked? They asked me, what is FH? Did this answer that question? No, it doesn't. Do you follow me? So what do I always go back and reread my question. Once I do some math and I think I'm done, I go back and I look at the question and go, did that actually answer? Because there's going to be multiple steps in some of these questions. In this one, you'll see it. Did this answer the question? So what do I have to do with the x in order to get the question? Yes. So first, I have to plug the 7 into this equation to get this length. Yes? When I plug in, what do I always use? Yes, but what did I put it in? Why do I have to put it in parentheses? Does that make sense? That will also be when we have, like, if I ask you to plug in x minus 1 into something, because you have to distribute it, and so it doesn't look like a 37. You're correct. What? What are you talking about?
You said after the. That's what we're trying to find.
What are you saying?
I'm saying that if you were to knock the 7 in parentheses in this equation, definitely not in other equations, this would work. It would be 37 minus 1, and the answer is 37.
No, that you're getting lucky. That's just a coincidence. But no, you're actually no, because if they finished the problem, they would still add the 16.
No, because this would be 20. If it's 21 right here minus, and then add 16, that's 36.
I understand. But if they did the question right, they would take this 36 that they're doing wrong and add the 16 to it. You follow what I'm saying? So no, it wouldn't be good. I understand what you're saying. 21 minus 1 is what? Now, what do you think some of you are going to do? And this is one of the things that I'm teaching you right now not to do. What are they going to assume? Look at this picture. The F to G looks what? Shorter than the G to H, doesn't it? So what do you think kids do with this 20? What do they think? Or they go, I must have done something wrong. Why? Because this looks bigger than this. Please, one of the first rules that we need to learn in geometry, you are not allowed to use your eyes to assume things. So just because this looks smaller than this does not mean that it is. Have you ever seen the thing on a rear view mirror that's like objects may be closer than they appear? That's kind of like what we're looking at with geometry. You cannot use your eyes to judge things. So I'll watch. You guys hear me, but you don't hear me. What is that? Wrong. Nope, wrong.
4 lines.
No, wrong. It's called a quadrilateral. It has 4 sides. That's all I can say. How come I can't say that it's a square?
Because you can't assume.
We can't assume that all those sides are the same. We can't assume that those angles are what? What do they have to be in order for it to be a square? 90 degrees. We can't assume that. You can't look at it. Now, if I said this is a square, and it's a square, I'm not going to say this is a square and then go, ha, trick. No, no, no. They say in the problem it's a square, it's a square. Or if they draw a picture, is this a square?
Yes.
Nope. That's called a rhombus. Is that a square now?
Yes.
Yes, it is actually. That one is a square. Okay. What is this? It is not a 90-degree angle. You're assuming again. It could be an 89-degree angle. I'm trying to blow your mind right now so that you guys understand how serious I am with you are not allowed to assume things. Okay? It could be an 89.9.
That is an angle, and there's
Now, what is this now? Now it's a 90. Now you can say it is.
that's an angle.
These 2 triangles are what?
Triangles.
Are they the same? Can you look at them and go, but they look like if I told you this was 5 and I said this is X, some of you would still go, this is what? 5. And that's not the case. You can't do that in geometry. You got to get rid of that habit. It's a bad habit. Okay? We cannot assume things. We got to prove them or they have to be told to us. Am I done with this question yet? What is 20 still? What is 20? Only the distance between what? F and G. If I wanted FH, I have to do this whole thing. So I'm going to do 20 plus 16, which would be 36. And that is my final answer. And this is what your homework paper should look like when you turn it in. I should not see just a 36. If you try to turn in a 36, I won't give you 5 points. If you turn in work, but you don't get 36, but I can see that you tried, you will get 5 points. It's about your effort and really authentically trying. Open your books, those ones that I asked you to have. Turn to page 2. On the bottom, there's an example. It says, try it 3. That's why I need you to bring those, because they have sometimes examples that we can try in class together. On the bottom, try it on your own. Yep. Page 2, example 3, it should say like JKL.
Oh wait, I don't have that.
Do you have the other? Yours.
Think about what now? What did I say about geometry? We only got 12 minutes anyway, so it's not much. What's the thing about geometry? What did I say? Is that going to be exactly how I ended up there? Is the thought process going to be similar? So look at what they gave you. Think about the addition postulate. How can you add those segments together to get the full thing? What are you trying to solve for? Like, this is called thinking, right? Think through that problem. turn in your homework, I want it on a separate sheet of paper. Whenever you're doing your notes or anything like that, I don't care where you do it. Yes, you will have homework. I will show you the way that I would do it. I hope that you start to do it kind of in the logic and the way that I do. Because like I said, when you get to Algebra 2, I will take the entire board to do a problem. And if you learn how to kind of keep math organized for these little easier ones, you have a process. You won't be able to kind of do that in the bigger problems that we do in Algebra 2. Right? I promise I'm not setting you up to be like failures, I promise. Yes. I'll tell you guys, it equals 4. 4 is in. I don't really care about the answer. I care about the process and doing the math right, being able to combine like terms and understanding that whole concept.
So then what was better on just having you
Yeah, I'll show you mine. Good job. You can have someone around before.
actually my next question?
So what was the question you first shared? A was yeah. These that were those. And remember I tried to this plus this or this plus this equals this whole thing, right? What did they tell you that whole thing is? 2 and 3. There you go. There it is. Huh? Ask a question. When I'm going over it, make sure you ask. All right. So you don't understand any of it, right? So you have to ask a question. You have to look at it and go, I don't understand this part, and then I can explain it to you. But I hope you understand what a line is, right? So I mean, you do understand some of it, so we have to figure out which part you're getting confused on. But I'm going to explain it and see what happens. All right, so we have this line. And again, this is the proper way that I would start organizing things because I know where you're going. I teach Algebra 2, and I'm also, while I'm teaching geometry, I'm trying to get you ready for that class. Okay? Okay? L. Does this mean that Does this mean that JK is longer than or shorter than KL? No, we can't assume with our eyes, right? They said this is 3n. They said this is 5n minus 7. And then they told me later on that this whole thing is 25, yes? Or what did we say about the angle addition? If you take the piece JK, so if I take JK, this is how I would organize this, that segment. And you add it to what? KL, this section right here. You would equal this whole section right here, which we would call JL. Does that make sense so far? Now, what is the value of JK? What did they say it's worth? So instead of JK, we're going to put 3 in because we're trying to find the distance of it, and it's equal to 3n. Does that make sense? Plus, what is the value of this one? And what is that supposed to equal? What did they tell me this value was? And then I am going to combine like terms. 3n plus 5n is 8n minus 7. Then I'm going to add 7. Brody, do you see how organized mine is? Do you see how you can see my whole thought process? Yes. Equals 32. No, 35. Yeah, 32. And I divide by 8, and divide by 8, and I get n equals 4. Yes. No. So it's counting. It's like how many, if I had a whole bunch of Green Bay jerseys over here, and I had another closet full of Green Bay jerseys over here, so I had 2 here, I have 5 here. How many do I have total? 7 what? Did they change the Green Bay jersey squared? When you're adding, you're literally counting how many you have. It is literally saying I have 3 ends over here, I have 5 ends over here. When I put them together, how many do I have? 8 ends. Does that make sense? When you multiply them, here's why you're getting that confused, and it's a common mistake. When I multiply 3 times 5n, that's when I get 15 ends squared. But what's in between them? A multiplication sign. You follow? Did that answer part A for me in this question? Yes, that was part A. What did part B ask you to do? Find the length of this, right? Well, you plug in 4, what do you get for JK? Because you do 3 times 4, which equals 12. You do KL, which is 5 times, plug in with parentheses, 4 minus 7. This is 20. 20 minus 7 is 13. So there's your 2 answers. How could you have got 13 different than the way I just did it? What if you knew this was 12? How could you figure out this was 13 without plugging it in? Yeah, if you know this whole thing is 25 and you know this part is 12, you know this has to be 13 because 13 plus 12 gives you the full 25 you needed. I don't care which way you would use to get the KL. Does that make sense to you?
Yes.
Are you starting to understand logic?
Yes.
Okay, this is how math is. It is not going to be straightforward anymore. You're going to have to start using the concepts that I teach you and apply them in a little different manner. Okay, yeah, put those back. We'll use those tomorrow.
Here's an interesting way to think about that.